Man. All right. Hello again, everybody. For those of you that are just now joining us for our last session, welcome to CSINext procrastinator sessions for everyone to catch up on their end of year required credits, learning units, HSWs, all that happy stuff we need to keep our certifications and licenses and professional designations current. For those of you that have been with us for the first 3 sessions, thank you for returning again. We're on the home stretch, and our presentation for this hour is a case study presented by Chris Bennett and Kristina Abrams and Mr. Ryan Stoltz, navigating the design process with low carbon concrete design intent. And I know this is a hot topic of late with the focus on carbon reduction. Some of you may recognize Chris Bennett's name. He's presented to this chapter multiple times, and he's also contributed to several articles within the construction specifier, and is definitely a go-to guy on concrete. Anything concrete, I guarantee you Chris probably knows something about it, and if he doesn't, he knows somebody that does. So with that, I will get it turned over to everybody here. Let these fine folks introduce themselves, and we'll get on our way.
Hi, good afternoon. I'm going to get us kicked off here. Welcome. Thank you for attending today. We are going to today discuss with you the hot topic of low carbon concrete, specifically through a case study. We have active work right now. The panelists, presenters today are all on a project team. We are teammates, and we are all working on executing low carbon concrete. And so we hope that we can share some really helpful input with you and real data. There's a lot of information out there. It's hard to organize behind it sometimes. So let's go to the next slide if we can. I lost the presentation on my end. Ryan, if you're going to share it.
Share that again.
Oh, there we go. Try it.
Coming up.
All right, cool. I see it.
There we go.
Yes, thank you to CSINext. Thank you to iSCS for inviting us and for putting this together. And I will let everyone here introduce themselves. My name is Kristina Abrams. I'm an architect. I'm also involved in CSI, member of iSCS, and a lead AP. I work as a specification writer, write the architectural specifications for O'Connell Robertson, and I will hand it over to Ryan.
My name is Ryan Stoltz. I'm a structural engineer at Structures in Austin, Texas, and we do work all over the country, a little bit internationally, primarily focused here in Central Texas, and help lead the office here in Austin. And Chris Bennett.
Hey, good afternoon, everybody. My name is Christopher Bennett. I own a concrete consultancy based in the Pacific Northwest in the city of Portland, Oregon. But similarly, we work all over North America as well. Primarily, we represent owners, developers, but work obviously very closely with AE teams in helping oversee documents and execution for, among many things, improving the quality of low carbon concrete and risk management, which is what we're going to talk about today.
Great. So this course is registered. Thank you to CSINext for doing that. We have 4 learning objectives. We're going to hit on real quick here. We hope that you walk away with a better understanding of what internally cured concrete is. Our approach on the project that we'll be discussing is to use a nano-modified cement as an admixture. We're going to talk about how that doesn't also have to translate into more expensive concrete and higher budgets for concrete. We hope you become familiar with the required benchmarks, the field quality control, the tools needed, why we measure the benchmarks that we measure, why we set them in our spec. We'd like you to better understand the polishing process and how the correct polishing can help reinforce durability in the concrete and improve the aesthetics. And also we'll talk a little bit about coefficient of friction, slip and fall. We hope you know 2 benefits and can list 2 challenges of high early strength concrete. All right. So first, we're going to talk through this. What is low carbon concrete? If you look at an ingredient list in concrete, it's not that long. It should not be that long. And if you look at how each of those ingredients are made, you will see that cement, of all of the ingredients, is the most, it's energy intensive, and the result is high CO2 emissions. There are a lot of factors out there, or percentages out there. X percentage of the industrial sector, CO2 emissions attributed to cement manufacturing alone. So that's why when you hear low carbon concrete, what we are probably doing, whoever is involved, is looking at reducing the cement content. Cement is also a very high cost ingredient relative to the other ingredients in concrete. So, if we're reducing the cement in concrete, wouldn't it also make sense that we would be reducing the budget? So reduced cement reduces CO2 emissions equals low carbon concrete. I just want everyone to know that. Now let Ryan talk a little bit about fly ash.
Sure. So to talk about fly ash, another key ingredient commonly seen in concrete, it is a byproduct from burning pulverized coal and electric power generating plants. For the past few decades, pretty much my whole career, sustainable concrete has been viewed as basically how much cement can you replace with fly ash. It serves a similar purpose as a cementitious material, actually has some benefits that can help the concrete durability. It has some other drawbacks, but primarily over the past few decades, fly ash replacement has been the main means of reducing the amount of cement and therefore the carbon emissions in concrete. I want to highlight a few key changes in the fly ash market that I've learned relatively recently, and have found that most engineers even that I've talked to are not necessarily familiar with the current state of the supply chain and what goes into the concrete. There's significant gaps between supply and demand that didn't used to be there for the fly ash market specifically. A few keynotes there: in 2015, 50% of the electricity in the country approximately came from coal-fueled plants. That has since changed, and it's dropped to 20 to 25%. And that change, the coal plants primarily run in very hot, very cold weather to supplement the grid. They're not necessarily the primary forms of electricity like they used to be. So therefore, the production of fly ash is a little bit more seasonal. It's not as reliable as it was 8 to 10 years ago. So that is a key change as we're talking about concrete. You'll see in an example later where, and some of you may have run into situations where there are fly ash shortages and we have to go back to some straight cement mixes. Fossil fuels have obviously been a primary target for environmental activists. That's helped reduce the amount of electricity produced from coal-fueled plants. China and India are actually ramping up the number of coal plants, and their their production of fly ash is increasing. So geopolitical circumstances are tricky and interesting, but the U.S. demand is probably pushing the demand for fly ash and the production of fly ash to overseas, where it will then be put on ships and shipped back over to the U.S. to be bought. And again, you can ask your question there in red: is the mix still low carbon if we're importing fly ash from across the pond? Complicated question, but it's always something to be thinking about. Fly ash produced, I thought it was interesting that 69.4 million tons of the fly ash produced in those 4 years between 2015 and 2019 were used in concrete, but 77 million tons were disposed and not used for various reasons, whether it's trucking or limited supply chain. It really is kind of a local material, but the way it played out, really a majority of the fly ash produced in the coal burning plants was actually not used in concrete. It was disposed of. Last point, fly ash production is going to remain relatively consistent, is what the industry thinks, for the next 15 to 20 years. But where we're at, it will continue to have some reliability challenges and won't always be as consistent as it was, again, 8 to 10 years ago. So reduced supply causes an increase in cost. So this is a concern kind of on the owner's side. I know here in Texas, we constantly hear the price of concrete continuing to go up. I think that's consistent across the country. And you'll see an example we did here in Waco, where we've implemented some technology to hopefully reduce the cost and find a reduction in carbon. Chris, did you want to highlight anything specific here on this slide?
No, I guess just the overall point is, fly ash, there are great attributes with fly ash, and there are also some drawbacks. Slow strength gains, delayed day of strength certainly being one of them. But I think more importantly, there does seem to be a narrative that if you're removing cement, you must replace it with an SCM, you must replace it with a fly ash. And that's simply not true. The removal of the cement itself is what's going to cause that initial lower carbon.
All right, so we want to reduce the cement. We want to reduce the concrete budget. So some things about low carbon concrete and cost savings. So low carbon concrete can introduce cost savings to the owner if the materials replacing the cement are cost less than cement. If the training and the mock-ups provide opportunities for subcontractors to become comfortable with the material, with working with the material, and we'll get into that a little bit more, resulting in a realized savings. They realize that this material does the things that we say it's going to do when we're talking about it during design, but they don't realize that until they're training. Or they're getting their hands on it, and then they can actually, in a fair way, address a budget for it or estimate the cost. Performance properties of the mixed design could also result in opportunities for schedule savings. All right, we can't talk about this without addressing curing. So we want to do a little internal versus external curing, and we want to start with assuming that most people here are familiar with external curing. So I will let Ryan take this one.
Sure. So just a brief reminder, an external curing is the primary format used to cure concrete and to help it gain strength. The importance of curing can't be understated. The need for the cement to gain its strength, to have time to cure, is the most important part really in attaining a high strength, durability, a high performance concrete that's going to have a long life. As you'll see in the diagram to the right, there's the yellow line or gold line at the bottom, doesn't have any cure time. If you cure it for 7 days, you gain, again, about significant strength there. You gain 20% strength or so. Another to 28 days, you cured another 3 weeks, you gain another 15-20% of strength. And then if you cured it indefinitely, that strength would keep rising, actually. It's really when you stop curing it, stop giving it moisture, that at some point that hydration process, the hardening of the concrete does stop. So huge difference. And I know here in Texas, we here at the top have primary ways that ACI recommends to externally wet cure. You can ponding and immersion is usually for smaller slabs, really spraying, fogging, and saturated wet coverings like burlap, plastic, covering with plastic, or left in place forms for walls or columns does help retain that moisture, and you can leave the formwork on to allow that curing to happen over a longer period of time. External concrete curing has a significant schedule impact and is often overlooked critical step. I know here we fight with contractors to get 3 to 5 days of curing as best we can, even in the heat of the summer. And really, we recognize a majority of the concrete that is poured on our jobs probably is not cured at all, maybe for a day. But there's a schedule impact. It slows people down. You can't get on the slab. You're kind of dead in the water, if you will, until the curing is complete. And so contractors are just raring to go and get that the curing done with so they can move on with the next steps. ACI in recent studies show topical densifiers and curing compounds are less effective than proper wet curing methods. So you might save time but compromise the quality, which can lead to mitigation and change orders later.
Okay, so we're going to talk a little bit about curing. When we say internal curing, we mean curing from the inside out. There are two different definitions. One is from the past and one is from the present, also, both by ACI. You may be familiar. But previously, internal curing was defined as, the aggregate, the large aggregate that you that is part of the concrete mixture serves as a reservoir for water. Okay, so when you soak it and it comes into the mix carrying water, it brings water as a gift to the mix, and it's mixed in evenly, and that aggregate is the internal, that's the source of the internal curing. But that definition changed, and it opened up a little, and this is not, this didn't just happen this year, so I'm just getting you up to speed. But the process, but the new definition doesn't rely on the aggregate as the reservoir. The aggregate doesn't have to be the one to bring the water to the mix. It can still bring water depending on how absorptive it is, but it's no longer necessarily locked into the definition. So, research, so the R&D has been happening on related to other types of, let's just call it ingredients, that you can use in a concrete mix design to help the concrete cure internally. So what can we put into the mix to help bring the water evenly in through the mix and let that concrete cure from the inside out? Let's keep going here. So innovation, and then also alignment with industry environmental interests. There's products out there. There's products that do this. And if you don't know about them, start doing some research. So I think I'm going to let Chris take this slide.
Sure. I would say since about 2013, our firm has been involved in commercial internal curing. I don't know if that's necessarily the longest with these newer types of internal curing measures in the world, but we had to have been pretty close to about the first. And like Kristina described earlier, it's about a way of delivering water more evenly so that the hydrolysis, the curing, is optimized. And there is a similarity there between the lightweight pre-wetted aggregates and what we're doing today, whether that might be with cellulose fibers, nanomodified cements, certain types of nanosilicas. A lot of these, silica, even at the nanoscale, it's still a rock, and it's going to still have that water around it. Obviously, the scale impact is different. But what this is going to mean through more evenly curing a concrete system is less volume change. So less curling, less cracking, less efflorescence. And if you're removing cement, less sort of hemorrhaging negative reactions from the concrete mix itself.
All right, and anyone who knows Chris knows that he's great at with these metaphors of think of it like this and think of it like that. And one of the things that stuck with me is the pomegranate seed. So if the seed in there is the cement particle and that membrane that carries the juice around with it is sort of what happens when we introduce a curing agent that can react with the cement particle at a nanoscale. Now, that aggregate that brought water at a nanoscale is the little seed, and it's evenly mixed throughout the concrete mix, and it makes water available on demand at a nanoscale. So we're internally curing. Okay, we're going to talk a little bit about our case study, get you oriented. This is Waco Independent School District. Kendrick Elementary School is an existing elementary school. Now it's a new elementary school. It's a public elementary school. It's 2 stories. We're using a local construction manager, and there's a desire and a goal, and it's something that's important to us, a mission to promote local economy, to advance, and the local economy is passionate about advancing trades. And so we've got to be sensitive to that. It's a public bidding project. It's going to go to public bid. We treat projects differently when we have complex clients and public bidding situations. This is important to know. And this is really important too. We have 3 school building projects in the district currently under construction or just finished construction that that we can use they are their approach is traditional cast in place concrete, and we have very relevant comparable data. So we have approved submittals from those projects. We know basically what would happen on these projects if we went traditional. Where would the materials be sourced? What would they be? And that's really good for us to be able to compare and keep ourselves on track. So the goals that we set for the project, we wanted to increase the strength speed. So we want to hit our requirement for strength, but with the internal curing, we'd like to get there quicker, okay? Low permeability. When you have internally cured concrete, you end up with a lowered permeability slab, a denser slab, fewer voids, less volume change. And by volume, we're talking about water over the life of the slab. And let's see, water reduction. We want to optimize the water that we do use in the mix. And we don't want, when the mix leaves the batch plant, to have to continue to add water. So we are trying to control the amount of water we're using, and we're going to use less cement. This should result in a lower permeability slab, more durable, higher strength. It'll be harder sooner, and we think that it will last longer, be lower maintenance than a typical concrete slab. All right, so we wanted to just go through a traditional mix. So a traditional mix, the ingredients are on the left. These are things that may or may not be, they may not all be in the traditional mix, but they're very common in the mixes that we had on the 3 projects that are currently under construction. So we got the coarse aggregate, the sand, cement. Sometimes it's type 1, sometimes it's 1L. Our average water to cement ratio there, the range that we've seen locally recently. And I put an asterisk next to fly ash because on one of our projects recently, under construction, we did have a situation where there was a fly ash shortage. They could not get fly ash. And it was either going to be a delay to the project or we were going to have to go straight cement. And that was going to be more expensive. No one liked that experience. So in this approach, we are not using fly ash. We are taking it out of the mix. We want the pure ingredients to shine. We're not going to complicate it with any chemistry that we didn't see coming. So no fly ash in this internally cured concrete mix. No admixtures with the exception of that curing agent, which is actually a nano-modified cement, which we treat as an admixture to the mix. We have to talk about curing materials too, because there's savings here. When we internally cure, we don't need any of the traditional curing materials. Can move. And then, yeah, no, we can go. Yeah, because that, yeah. And then we just want to talk about the design timeline, the process. So in at SDs, we already had an approach and language in our narrative describing internally cured concrete. It was already there at SD. It's not something that you can decide later than that. Wouldn't recommend doing that. You can do it. But in this case, we knew that it was going to be a journey for everyone to learn what it was that we were doing and make sure that it was what we wanted to do, make sure that we had a strong team to support the execution of the work. So we had it in there at SD, owner, architect, structural engineer, really critical that Ryan was, open to learning, thinking about this differently. Not all structural engineers will do that. And then our concrete consultant, of course, Chris, which was amazing for him to come in with the experience. This is how I've done it before. This is what we find, that type of thing. At DD, we should already have, if we have a CM on board at that point, and they are in the loop with this design intent, that's when we get an estimate. And so that's a really good time to look at that estimate and say, are the numbers reflecting business as usual? Or are the numbers starting to try to acknowledge what this means to the budget, for the budget? I think that's really important. It's a good check-in for how much do we truly understand this? Look at the numbers. So we're educating. We had presentations talking about what is internally cured concrete. we are adding to our team. Now we have, make sure the construction manager's in the loop, and make sure that you are in touch with, at this point, you probably have an approach to the low carbon concrete, unless you're leaving it open, but you're doing research, which means getting in touch with the manufacturers of the admixtures or the products that you are relying on to help you achieve that low carbon goal. In CD, we're engaging subcontractors. So in CDs here, we realized that we weren't getting we weren't seeing the numbers change in the estimate. And that was the true tell for us, that we wanted to see what was going on with our community of potential subcontractors, what was on everyone's mind. So we held a town hall, and we can go to the next slide.
Real quick,
Oh.
Kristina, can you jump back to the slide before the breakdown between phases? There was a question. Previous slide said no control joints. Question was, how does that work?
Sure. I think Ryan, you or I can take it. I'll jump in here. So you've got control joints happening when they're required. Obviously, the type of slab is going to dictate whether you need them at all. But by maintaining most of the volume, not having it bleed out into the atmosphere as vapor, your movement in the slab is reduced to the point that the need to adjust for some of those changes, as you see with commonly curing or not curing with resinous materials, silicates, things like that, are going to be reduced, if not eliminated. On the operational side as well, this is handy because 60 to 70% of your maintenance and your headaches for facilities, particularly with hard-wheeled traffic, are going to come from constantly needing to repair those joints.
Mm-hmm.
So there are of just, kind of doing it right the first time and making sure your volume change. You can't do anything about thermal change, right? The sun will always be the sun, and it's not much we can do about that. But hydrolysis, that's something completely different, and we can exercise a lot of control to the point of significantly reducing undulation, curling, and certainly the need for joints.
Right.
Ryan,
Thanks, Chris.
you wanted to add there?
I think you covered it. That's good. We'll keep moving.
Thank you.
Okay, so we're gonna get back to we touched on the team, but this is the core team right here: the owner, the architect, the structural engineer, the concrete consultant, construction manager, if you have them on board, subcontractors, we'll expand upon that, third-party testing facility, critical, and then manufacturers of the cement technology product that you're using, and very, 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 very important to have them involved. All right. Subcontractors, it's a much longer list than you think. We're not just talking about the ready mix plant supplier as one person. There's the ready mix plant QA team. Okay, if you haven't met any of them, 2024 New Year's resolution, go have lunch with a ready mix QA member and engineer and just talk about concrete. Ready mix truck driver, there's technology on these trucks, and that technology requires support and part replacement. If you're relying on X number of trucks to deliver your concrete on time, and it can only be in that truck for so long, you better make sure that not only is that technology benefiting you by being able to keep your mix at the correct water to cement ratio and everything else, but also that if one of those trucks breaks down, that doesn't throw you off. So pump truck operators, who's the pump truck operator taking direction from? Formwork installation placement team. So these are all subcontractors, people who need to be in the loop when they see something that works differently. We don't want them to start to do what a lot of people might do, which is revert to their default settings, which is doing what they've always done. And there it is, my default setting slide. So you're going to hit a lot of this, and I think it's just important to notice. Okay, outcomes of the town hall. So we had what we called a town hall. We created a mandatory meeting for all of the CMs and all of their potential subcontractors, all the people that they think in the community might bid the project. Invite them to this town hall. We want to talk about internally cured concrete because we can see that the numbers are not changing, and we want to make sure we do everything that we can to bring everyone into alignment and build a strong team. So what we heard, we had ready mix suppliers in attendance. They said, we don't have any tested mix designs for the mix specified on this project. And the ingredient that we are unfamiliar with is this nano-modified cement admixture. So how can we bid it? How can we give you an estimate if we don't have a tested mix design? The placement subcontractors were like, yeah, we want to get our hands on it, but can we do a mock-up? Can we do it sooner? Can we work with it sooner so that we have a better idea of, you know, the labor requirements? Is it different? Does it require different equipment? Does it take longer? The schedule savings is a realized savings. So basically everyone in the room said, you can tell us it's going to take less time and we can reduce the budget for the schedule, but we're not going to do that because we've never done this. Also things we heard were, you know, this is new to us. We've never done it before, so we're going to charge you more. It was very transparent and it was an excellent meeting. So what did the design team do? Well, we decided we were going to have a mandatory pre-bid mock-up to help qualify subcontractors and also as some sort of an, you know, give back to the community. If anyone wants to come and learn about low carbon concrete, it was made open. Okay, but the goal was to have 3 tested mix designs. We decided we were going to do 3 slabs, 3 different mock-ups. Each mock-up was assigned a different local ready mix supplier. And that ready mix supplier was teamed with one of the admixture manufacturers. So each team was going to pour one mock-up and place and finish and all of this stuff. So we had, we also wanted to make sure that it happened at least 28 days before bidding because we were trying to pre-qualify and we wanted to make sure that we had time to collect all of the data. We wanted to use the mock-up opportunity to train on measuring benchmarks, train on workability, placing, finishing, polishing, all of these things. And then we wanted to offer the subcontractors certification, those who stick around, those who work with the material and want to be certified, that they would have that opportunity to be certified. And we did. We issued pre-bid mock-up requirements as part of a specification. We described 3, this is what's happening. These are the teams. This is when it's happening. This is what the mix design intent is. Each ready mix supplier was given the same exact mix design intent. They were not to stray from that. It was just the same exact ingredients with, you know, and we made sure of that. And then we asked of the ready mix suppliers, we required that they submit a pre-mock-up submittal. So now we're doing pre-bid mock-ups, pre-mock-up submittals, see how everything's pushing back and we got to think ahead. The pre-mock-up submittal was a cement mill test report. Why? Well, this is a big, you know, it's ingredients. It's a chemistry experiment. You know, we have to think about all of the things going into the concrete mix. And, you know, we don't always get Portland cement type 1. Sometimes we get 1L. And we wanted to see where is it coming from so that we have the opportunity to find anything that might change the way that we think that this concrete will behave in the mix that we have planned. All right, so here were our teams. This is what we gave as our mix design. And I want to say we had a 0.4 water to cement ratio. That meant, you know, after the truck leaves the batch plant and we confirm the 0.4 water to cement ratio, we are not adding water. Here's our layout, mostly to correspond with the cylinder sets that you're going to see later from Ryan's data. And then outcomes of the pre-bid mock-up. We had great participation. We placed 3 slabs. We had testing data from 3 slabs. So we had the tested mix designs that we needed. We exceeded our benchmarks. We achieved large aggregate exposure on one of the sets, and we reduced cement by 30%. And where do we need more work? Well, our wheels were spinning after this. We needed more work. We needed to make sure that there was fluidity from the batch plant to the placement. You know, that day the trucks arrived late and then they weren't staggered the way that they thought we'd be staggered. So there was some equipment that was being shuffled around, trying to make sure that everything was finished on time at different slabs. We had interruptions in pumping, which ended up, which resulted in, because the mix had already been in the truck for longer than 90 minutes. We went to tailgating, and there really wasn't a clear chain of command on site. This was before the project moved into construction. So it's a conversation to have with the architects and the CMs and the owner. Hey, who's going to be in charge? Who's the boss on the site that day? Because we're not yet into construction when there's like a natural progression towards the contractor taking over that type of activity. And too many human variables. It was open to humans. It was a wonderful activity, but we weren't sure when we collected our observations why certain things happened. So we proposed mock-up number 2, and we were going to improve on all of those points. So we're going to look at the specification and definitely require pre-installation meetings, start adding those pre requirements. We were going to just stick with one slab. We were going to have a clear chain of command. We were going to have a dedicated subcontractor team all aligned behind the same goal. We were not going to be open to the public. We made some adjustments to bring the strength down. You'll see later, because it was very high in the first one, which was wonderful. And then also had other things that we made us think about. More time spent at ready mix plants, exploring aggregate absorption. So all of these things happened as part of mock-up number 2.
Awesome. Thank you, Kristina. One of the items that is, of course, very popular throughout North America and a requirement here for Waco ISD's Kendrick Elementary is that of a polished concrete floor. A lot of the marketing that will follow those two words, polished concrete, is sold as very sustainable, long lasting, very durable, right? Unfortunately, and I don't know what the exact percentages would be, but these days you are more likely to get either some sort of hybrid kind of polished coating, if not just an all-out 09 resinous substitution with some sort of clear coat because of our documents. And so what we wanted to make sure of is that we don't just have aesthetic benchmarks in the documents. Ryan, if you could go forward one slide here. A spec will usually have color, then, what size aggregate, and then it'll be either a level of reflectivity or it'll be a quality of that reflectivity. And those are great. You need them in there, but you can achieve those with polished concrete in about 1,000 different other ways. And so only having the aesthetic benchmarks in there, number one, it's certainly not going to, as a condition of the contract, mean you're installing something sustainable or protecting the owner, but the costs, the types of maintenance are going to vary wildly. So we wanted to be a little different. Let's go to the next slide. One of the, I guess, maybe not for all specs, but still fairly common, you'll see some type of grit designation, finish to 400 grit, start at 80 grit, end at 1500 grit. And a lot of specifiers believe this language to be very objective, when actually saying 400 grit could mean literally thousands of different things. What type of material is the abrasive grain? Is it a universal size? Is it an average size? What is the matrix of the abrasive grain? Is it industrial diamond? Is it metal chaff? You also have coating manufacturers that make resinous diamond tooling that, when they're superheated, they transfer their epoxy resinous material and create a shine on the floor. But because the box it comes in says 400 grit, 800 grit, just like your specification requires, they're technically meeting the conditions of the contract, even though it's an outright substitution. Some of it's not even malicious in nature, how it's happened. It's essentially coating manufacturers responding to a changing market and wanting to call their products polished concrete too, because that's what everybody's asking for. So we wanted to make sure that we're actually being sustainable. And so in addition to our aesthetic benchmarks, we were also adding in physical benchmarks, not just for polishing, but also finishing. And the two that we're going to talk about primarily are that of average roughness, or RA, the surface microtexture, literally measuring the peaks and valleys of a concrete surface. And we have conditions of the contract of a minimum RA for the finishing. And this acts not only as wayfinding for your placement and finishing crews, when can we start, when can we stop, but also we've all been in those situations where maybe you just get that horrible looking cold joint, or maybe somebody didn't do sun and wind protection or something like that, and the texture of that surface suffers from it. Well, in the past, there isn't any benchmark to keep the change orders from happening. It needs to be mitigated, and a lot of times the owner ends up paying for that, or maybe the entire project team dips down into their contingencies instead of the folks that, well, maybe didn't do wind protection, right? So it has a lot of great advantages within the specifications to provide a lot of value. One of the things that we noticed right away with the training, after we exposed aggregate, the polishing contractor came in, and the first time around did not have a profilometer device, an RA device. And I'm going to turn on my camera here real quick rather than go back a slide, just so everybody can kind of see that there. This is a profilometer, and there's a little metal stylus here. And that stylus goes over the peaks and valleys, all the nooks and crannies of that surface microtexture, and will give you a numeric reading. And one of the great things about doing that is if your constructor takes measurements, just like you would with sandpaper, and kind of measures what the starting canvas is at, they don't accidentally go into too abrasive of an initial procedure. Literally go back, and let's say the concrete was a certain level of smoothness, and so they could start and have reduced labor going forward. If they make it rougher by not measuring, then we found at this particular training that the contractor had added not one but two additional passes with diamond tooling for aggregate exposure and initial polishing of the grind, as well as two passes on the final refinement. And so just by measuring, right, just like you would, they say, measure twice, cut once with any sort of timber products. This is the same for concrete. If you are measuring your starting points and you're measuring as you go, and you have a designated RA target that you're trying to hit, now you can cost your labor. Now you can be very efficient with your mobilization. Let's go forward one more. There's another.
Hey, Chris, could you show that instrument on your camera again? Your background was a little blurred.
Well,
So,
if everybody will look at the screen right
there
now,
it is.
this is,
There we go.
yeah, this is a different make and a different model. The stylus is still under. You'll see there's like a little metal plate there on the left, and that is protecting the little stylus that comes down. And in this case, gave us a measurement of 19.50 microinches. And surface texture is measured in microinches. And for the conditions of our contract, the structural cast in place spec, we had an 80 microinch or less benchmark, and for polishing, 30. And so to illuminate a little bit on working with the contractors, they were already at about a 30 microinch level of the surface. and they introduced a tool that brought them, excuse my French, damn near close to 80 microinches. So they were literally going back in time on the schedule by making the surface way too rough. The other thing that they were doing, of course, is compromising the integrity of the crown. And so they said, well, hey, no problem. You know, we're going to come back here with grout coats and we're going to do all this kind of stuff. And these are all change orders. This is all degradation that's going to be a legacy issue for that surface. And so being able to walk them through, you know, not needing to use grout coats, not needing to use these sort of patch Band-Aid materials, and refining the concrete mechanically and chemically to meet these benchmarks really helped them be more efficient. And it helped them make more money. So the owner gets the schedule savings, but they also benefited directly because their labor and material costs went down. The last thing I think it's important to measure here too is Mohs. For those of you who are not familiar with the Mohs mineral testing, this is not on the micro scale. It's a handheld stylus, and they're of varying degrees of hardness. And they start, gosh, all the way from talc all the way up to diamond at a 10. And if you've got, and these are very simple measurements to take, whether it's a third-party engineering firm, the design team, engineering team, and most concrete that isn't, you know, kind of cured very well or sort of so-so cured is going to be somewhere on the 5, maybe as much as 7, if there's some wet curing, by about 28 days. And we were measuring 7 to 8 Mohs by day 1, the end of the day. So what does this mean? Well, it means your concrete's really, really hard, very, very quickly. So now we start thinking a little bit holistically about the rest of our schedule. We're going to have scissor lifts and wrench drops and spills and all sorts of things. What are the change orders going to look like if your concrete is measurably as hard as, say, dry shake on hardener already versus, you know, softer at about a 5 or a 6? You're going to spend more money. You're going to absolutely have changes to the aesthetics that aren't necessarily going to be welcome. And so again, it's one of these simple ways to measure what you're handing over to the client. And the sustainability, again, if your concrete is denser, if it's harder, it's going to last a much longer time than something that is softer. And when you're in a situation, and Mark, I know you do a lot of industrial facilities, if you're being told, hey, let's have a change order, we'd like to put on metallic dry shake hardener. Well, if your facility is already measuring at 8 plus, quantifiably, there is no benefit to adding on a metallic shake on hardener, which is also going to give you 8 plus. You're already there. So there's a cost element, there's a schedule element by just, again, measuring what your progress is doing. Let's go to the next slide here.
Chris, we got about 10 minutes left, just letting you know.
Okay. Let's see. I'm not going to talk too much about the difference between coatings and polishing. I think we already covered that. I'll say this and then I'll hand it over to Ryan. At the end of the day, what Waco will be receiving is polished concrete without coatings, without sealers, without sacrificial guards, because of the quality improvement of the slab itself, and then teaching operations how to take care of that slab to maintain the RA, which will also go to the next slide. I guess we do have a coefficient of friction, which will also directly correlate to high traction coefficient of friction. RA is a surface measurement, dynamic coefficient of friction, static coefficient of friction, that is a surface measurement. And there is a correlation. Now, there are also a lot of variables, but we can eliminate some of those. And what I have found in the last 10 years on my projects is that if you are fully refining floors. And even when you're at 15, 10, sometimes 5 microinches, you're still hitting consistently high traction coefficient of friction. Whereas a lot of specifications, you sort of throw it out there and you might require that initial decoff testing, but nobody knows how to maintain it. So this helps your school systems or whoever might be using the facility be able to not only maintain cleanliness, but also maintain safety. And Ryan, oh, perfect timing.
Perfect timing. Thanks, Chris. Here, last section, I'll get through this here by the end of the hour, and I'm sure we can hang on for a couple extra minutes if there's some questions. So some of the data we collected, I want to share real quick. This is mixed designs from another school in Waco that we'd worked on the previous year, and we had a mixed submittal that shows a typical cement plus 20% fly ash replacement. Fairly common. You'll see there 451 pounds of cement, 113 pounds of fly ash. So that's 564 pounds of cementitious material. We had strengths, again, by day 3, we had 3,000. They didn't take 1-day breaks. It was probably around 1,800 if I had to guess. 7-day, 3,600, 28-day, 5,200. So again, remember there, that's 5,200. And that was with 450 pounds of cement and 113 pounds of fly ash. We then were notified that there was a fly ash shortage, and it could be a month, could be 2 months till fly ash came in. They didn't know. So they proposed a straight cement mix. So for a few of the pours in the middle of the project, we did, for schedule reasons, have to approve a straight cement mix. So this mix was submitted, exactly the same amount of cementitious material. Everything else is the same in this mix, but you'll see 564 pounds of cement, 25% increase because we got rid of the fly ash. We replaced that with pure cement. And the strengths are very similar. Not much variation there. I think 5% variation in the 3, 7, and 28 day. Again, with 20% fly ash replacement, you're going to see fairly consistent breaks as you would with a straight cement mix. As you get higher, 40%, 60% fly ash replacement, you definitely see that delayed strength, where often we see the 56 days needed to get to the 28-day strength. A quick chart here just to note the impact of fly ash replacement. You'll see the red lines indicate a 30%, 45%, and 60% replacement of fly ash. And you'll just note here that a 28-day strength of no fly ash replacement could take significantly longer, as long as 28 days or even 56 days to get to that same strength as you start introducing high volumes of fly ash. So here is the slide with our mock-up 1, 2, and 3 strength breaks for the mock-ups that Kristina was talking about earlier for the elementary school in Waco. You'll see the curve, and our mix, going back to what was in the specification and what was required for these mock-ups, is 430 pounds of cement. So this is a lot less. And now you'll see in red the straight cement mix from the other school in Waco that had 560 pounds of cement. So it seems backwards. More cement should mean higher strength, but because of the internal curing and the admixture, with significantly less cement, we're able to get significantly higher strength. You'll see in day 1, we had 4,120. One of the mock-ups even hit 6,000 after 24 hours. So that's pretty eye-opening if you have some familiarity with concrete and what traditional breaks look like. 28 days, we got up over 11,000 on one of the mock-ups, which leads to the next point. It came in over 10,000, and my first thought was, wow, that's way higher than I thought. That might not be good. That may be too high. So we started thinking about some challenges of high early strength, demoing cutting concrete, future innovations. There are some calculations on the engineering side. Reinforcing steel tonnage can increase. Minimum steel requirements are based on concrete strength. It's the square root of concrete strength, but it does impact your minimum steel. So you need to be aware if it is getting too high. Post-installed anchors, powder actuated fasteners may be impacted. recommendation, always perform mockups. Local materials are going to vary. It's going to be different. You need to take cylinder breaks with that mockup and require that in your specifications. And remember that higher strength is not always necessarily better. There's some challenges that could come with that. So here's a quick screenshot of Hilti's XU and XP fasteners, often used to secure light gauge track, for example, to the slab. And you'll see over on the right side at 8,000 PSI strength, the XP fasteners have a value, but they didn't even test the more economical XU fasteners. We were over 11,000 at 28 days. We'd have to get with the manufacturer, probably do some testing to kind of confirm that their premium fasteners would still work. So something to keep in mind, could be a cost impact there. The benefits of high early strength, polishing started on day 2. After 24 hours, we had a strength where we wanted to get on the slab. We tested our benchmarks, our Mohs hardness. We said, okay, we're good. Let's get on there and start polishing after 24 hours. Significantly less time. That means mobilization for equipment and next trades could be day 3 or day 4, depending on the polishing and the finish needed for the project. For tilt wall applications, you could lift walls after 24 hours when design strength is achieved. A huge advantage for schedule. And again, dense, low porosity concrete is less prone to moisture differential, and that can reduce curling, warping of slab. You have denser concrete, and it's going to prolong the life of the structure. Did a quick example of a benefit of high early strength, a cost example. Talked to a few contractors, and these are some rough numbers. There's a lot of variables in this, but just wanted to give another example of a $50 million budget is the example I kind of did here. 80,000 square feet, a 16-month schedule. The estimated time and material savings for the concrete pours was about 2 weeks with the higher early strength. Reduced dollars per square foot of finishing and topical projects. Save $5 per square foot. It's a conservative estimate. I think with the things Chris talked about earlier, could actually be significantly higher than that, but we took a conservative number. So the estimated schedule reduction savings is $780,000, and the estimated material savings for this example we did here was $400,000. That's a savings of 1.2 million. That's 2.4% cost reduction just coming from high early strength concrete and the benchmarks we talked about earlier. So I think the main takeaway there is we're not talking about a lot of extra time in design and meetings and talking with concrete contractors to save $10,000. This is a significant amount of savings that really is worth it. And Chris, you had something about a 20% cost increase in your area. I think you wanted to mention here as well.
Sure. With a lot of the clients that we work with, when they've got their initial budget projections to meet low carbon concrete, primarily up in Canada, where the low carbon regulations go into effect here in the next 6 years. Across the board, everybody's increasing their concrete budgets by about 20% and assuming that their construction schedules need to be lengthened because of delayed day of strength. And so the fact that you can still meet those obligations, whether they're municipal, whether that's whatever that might be, if you start to dig into, Kristina, you were mentioning this today, dig into your submittals, see what's actually happening. And low carbon concrete doesn't have to be cost prohibitive. It doesn't require delayed day of strength at all. And so make sure you're looking into some of those details where you can make something an obvious win for the client by reducing budget and reducing schedule, improving overall quality rather than going the opposite direction.
Yeah. And to kind of wrap it up, one of my favorite quotes that I want to kind of end with. We shared a lot of technical information. But again, if you want to go fast, go alone. If you want to go far, go together. And I think one thing we learned on this is that having a team of like-minded people, the owner, the contractor, Chris, Kristina, myself, others involved, we didn't give up. There's times where it was hard. We had to push through and find ways to innovate and to get everybody on board with these new ideas. And I'm so glad we did, but it does take a team. So I challenge you in 2024 to find like-minded people, innovate on your projects, and try to find new ways to help the owners out, make your projects better. build with better concrete and better specifications, and enjoy doing it. I know it was a highlight of my year, and I think Kristina and Chris would probably say the exact same thing. So thanks for your time today, and I think we'll open it up to any questions.
Yeah, thanks, guys. It was a lot of information, a lot of technical information, a lot of good information. I'm still a little leery of the no control joint deal, but that's just me as a construction manager, because if there's one thing we watch like crazy, it's control joints and cracks. And I know concrete's supposed to crack, it's what it does, but it's always a hard thing to explain. Do have one question here. Actually, I might even evolve into a couple more. On the mock-ups and all the stuff that was done pre-installation wise, what was the buy-in level from the contractors on that? Because there's, I mean, I know schedule, and I know more than probably, everybody knows from schedules that schedules are tight. You never have enough schedule time to begin with. And when you get, I don't want to say bogged down, but when you start doing these mock-up samples and then it's like, well, that's not quite right, we got to do it again, it starts adding. We all know that time is money. I know that, some contractors are really into this stuff, and others are like, we're wasting our time with this stuff. So what was the buy-in level like, and was there any, what kind of difficulties or what learnings came from all of that?
If I could hop in real quick and kind of address the elephant in the room, your contractors and your suppliers are not going to do anything unless they're making more money, period.
Right.
If you go to a builder with the owner and go, hey, I got this great idea, we're going to take a bunch of scope and budget, we're going to take it out of your pocket and give it back to the owner, nobody is going to be excited.
Right.
So you have to do two things. Number one, you have to incentivize your supplier team. When you take out, in this case, 30% cement or 40, 50% cement, the cost to produce that concrete material is going to go down.
Mm-hmm.
As long as you can deliver the performance benchmarks, your ready mix supplier, your mobile mix supplier, they've made more money. The same with shrinking schedules, reduced labor, reduced mobilizations. But it is key to have the owner involved in these discussions so that your supply team members and your constructors are watching the owner become aware of the schedule reductions, become aware of the cost decreases, because then they're in the position where they have to share that. And people like Ryan, Kristina, and myself, we're in place, to make sure that happens. But really, the having everybody work as a team, but it comes down to what's in it for everybody, mm-hmm. and you've got to make it worth everybody's while. But mm-hmm. the owner has to benefit too.
Yeah. How do you see this type of low carbon effort evolving over the next, say, 5 to 10 years?
Kristina, what are you seeing specifically in Texas?
Well, with the introduction of LEED 5 being carbon focused, when we talk low carbon, concrete it comes up. It comes up sooner than you think. If your local jurisdictions are sustainability focused, they're already learning about it, or encouraging those who they consult with to learn about it. Everyone is sort of who is trying to make sure that they don't get stuck in a situation where they have to do it and don't understand it, is learning right now. And so I guess what the result of that is a lot of talk about things that maybe are less real. And so what I would say to your first point is the kind of concern you expressed, or the energy you brought to that question, exactly what we saw the entire time, over and over, until it was poured, finished. polished. Then the light bulb went off and
Mhm.
people wanted to own it. We need a team where everyone feels equal ownership and excitement over this, and everyone realizes it at a different moment in the process. And so you kind of have to know that to be able to stick there through the process and support each other and everyone during the process. And so yeah, I mean, I think that everyone needs to be learning about it now. You know, as an industry, as architects, we're challenged to do better. And concrete is something that a lot of architects don't actually get into the weeds with, honestly. But I, I don't think I would say so.
I know
We need to
recently
learn
here
a
in Texas too, the Carbon Leadership Forum goals that they keep reducing, the local plants here can't keep up with them. I know the 23 values that they just released. Most batch plants here around Central Texas can't get within about 10 to 15%, and they're going to try to reduce them 20% again next year. But with that, some of the QA managers at the batch plants I've talked to, they're innovating, they're open to ideas, they're wanting to hear about low carbon options, and they want to learn about the internal curing that we did here. They said, come on, in January, let's pour some, we want to learn about it. So I think they're getting a lot of pressure, and the discussions, the politics are driving that little momentum there, and we're getting positive feedback that everyone is excited to keep pushing. They recognize that's where the industry is going, and they're more open to innovation than I've seen at any point in the past couple decades. So
one thing I will add is if you don't get involved in the conversation now and you have your area is dominated by some big ready mix giants, they are coming up with a solution already if they don't already have one for the request for low carbon concrete. And that request may not result in the things that we presented today: higher release strength, schedule savings, cost savings. They may be an a la carte 20% premium.
Okay. Any idea on how long it is until the Canadian regulations start to show up in the US markets?
I think it'll vary. I'm out here in Oregon, and the West Coast typically adopts those sorts of
Earlier.
a little earlier. But I was surprised when we went down and initially started these discussions with Waco Independent School District. City of Austin was already implementing measures. So it depends on kind of what city that you're in, but it's coming.
Okay. Next milestone for application and testings beyond just slabs. Are you thinking columns, beams, tilt walls?
we're going to test some tilt walls in January. So we're continuing with this to see what other applications might be might be a good fit for. I think there's a lot. Obviously, the higher release strength can open up your mind to utilizing that in a number of industries. But yeah, industrial tilt wall. I know 75% of construction approximately in Texas is tilt wall. So we're definitely interested in pursuing some mock-ups with that and see how that can affect schools and industrial where tilt wall might be used. So
yeah, and I would add on to that. At our practice, we've done a number of internal curing projects over the years. The nice thing about public sector is we're able to share some of that information, which has been really different for me in my work, but absolutely great in terms of a sounding board to share with others.
Okay. Well, I think, folks, that's gonna wrap us up, and it's been a long afternoon, but a good afternoon. You guys were session 4 of 4 and the first CSINext procrastinators sessions here. So again, to all of you that were on the presentation, thank you for attending. For all of you that made it through all 4 sessions this afternoon, bravo. We're looking forward to doing this again next year. Chris, Kristina, Ryan, thank you. Great topic, great discussion. And everyone, you should be receiving a survey at the end of this. Please feel free to fill that out. If you need AIA credits for this, please enter your AIA number in the correct blank there and just click yes. Any other comments you've got, there's a comment box at the end of the survey. We will download those, get those over to Chris and everybody so we can get those out to you guys, and keep your eyes on the horizon for CSINext presentation in January after the new year. And everybody have a happy, safe holiday season and a happy new year, and we'll talk to you in 2024.
Thank you.
Thanks, guys.
Thanks.
Bye-bye.